When selecting heat detectors with either a fixed temperature of 200 degrees Fahrenheit or a rate of rise of 15 degrees Fahrenheit, several options are available. These include the first alert SA3200, which has a fixed temperature of 200 degrees Fahrenheit. The system sensor H725 has a rate of rise of 15 degrees Fahrenheit, as does the K1103. The notifier HR200 has a fixed temperature of 200 degrees Fahrenheit. When integrating these heat detectors with existing BRK4120B smoke detectors, compatibility is important. To ensure proper interconnection, a compatible base is necessary. The BRK-C121 is one such interconnected base specifically designed for heat detectors. The first alert HT-1 is a universal interconnected base, and the KID P1203 supports interconnection for both heat and smoke detectors. When installing heat detectors, safety and adherence to instructions are paramount. Firstly, always turn off the power to the circuit at the breaker panel before starting any work. Secondly, install the compatible interconnected base at the desired location in the attic. Thirdly, connect the heat detector to the base, carefully following the manufacturer's instructions. Fourthly, secure the heat detector to both the base and the ceiling to ensure it remains in place. Fifthly, after completing the installation, turn the power back onto the circuit. Sixthly, thoroughly test the heat detectors to confirm they are functioning correctly and are properly interconnected with the existing smoke detectors. Important considerations must be kept in mind. It is recommended to check local building code requirements to ensure the installation meets all necessary standards. If modifying the pre-wiring is not possible, or if compatible heat detectors cannot be found, it may be necessary to replace the entire interconnection system to accommodate the desired smoke and heat detection setup. Understanding the specifications of heat detectors is crucial for selecting the right device for a particular application. Fixed temperature heat detectors activate when the ambient temperature reaches a specific threshold. For example, a 200 degree Fahrenheit fixed temperature heat detector will trigger an alarm when the surrounding air temperature reaches 200 degrees Fahrenheit. Rate of rise heat detectors, on the other hand, respond to the speed at which the temperature increases. A rate of rise detector with a specification of 15 degrees Fahrenheit will activate if the temperature increases by 15 degrees Fahrenheit or more within a specified time period. Interconnected smoke and heat detectors enhance fire safety by ensuring that when one detector senses a fire condition, all interconnected detectors activate, providing an early warning throughout the building. This is particularly important in residential settings where occupants may be asleep or otherwise unaware of a fire in another part of the house. The BRK4120B smoke detectors are designed to interconnect, allowing them to communicate and trigger each other's alarms. When adding heat detectors to this system, it is essential to use compatible devices and bases to maintain the integrity of the interconnection. The bases mentioned, such as the BRK-C121 First Alert HT-1 and KID P1203, are designed to facilitate this interconnection. When choosing a base, verify that it is compatible with both the heat detector and the existing smoke detector system. Different bases may have different wiring configurations or communication protocols, so it is important to select one that is specifically designed to work with the intended devices. The installation process is another critical aspect of ensuring the effectiveness of the fire detection system. Turning off the power at the breaker panel is a fundamental safety precaution to prevent electrical shock during the installation. Installing the base securely and connecting the heat detector according to the manufacturer's instructions will ensure that the device functions properly. Testing the detectors after installation is essential to verify that they are working correctly and are interconnected with the other devices in the system. This can be done by simulating a fire condition, such as using a test spray or holding a source of heat near the detector to trigger the alarm. Local building codes and regulations often specify requirements for fire detection systems, including the type and placement of detectors. Checking with the local building department or fire marshal will ensure that the installation complies with all applicable codes. If modifying the pre-wiring is not feasible or if compatible heat detectors are difficult to find, replacing the entire interconnection system may be a viable option. This may involve replacing the existing smoke detectors with models that are compatible with the desired heat detectors, or installing a completely new system that is designed to accommodate both types of devices. When selecting a new system, consider factors such as the size and layout of the building, the specific fire hazards present, and the desired level of protection. A comprehensive fire detection system should include both smoke detectors and heat detectors, as well as other safety devices such as carbon monoxide detectors and fire extinguishers. Smoke detectors are effective at detecting smoldering fires, while heat detectors are better suited for detecting fast-burning fires that produce a lot of heat. By combining these two types of detectors, a more comprehensive level of fire protection can be achieved. The placement of heat detectors is also an important consideration. Heat detectors should be installed in areas where smoke detectors may not be effective, such as kitchens, garages, and attics. These areas are more likely to experience high levels of heat or smoke from cooking, vehicle exhaust, or other sources, which can cause nuisance alarms with smoke detectors. Heat detectors are less susceptible to these false alarms and can provide more reliable fire detection in these environments. When selecting heat detectors for an attic, it is important to consider the ambient temperature of the attic space. Attics can become very hot during the summer months, so a heat detector with a higher temperature rating may be necessary to prevent false alarms. The 200-degree Fahrenheit fixed temperature heat detectors mentioned are suitable for attics and other areas where high temperatures are expected. Rate of rise heat detectors are also a good option for attics, as they will only activate if the temperature increases rapidly, indicating a fire condition. The system sensor H725 and Kit 1103 are examples of rate of rise heat detectors that are suitable for attic applications. In summary, selecting and installing heat detectors for a residential fire detection system requires careful consideration of several factors, including compatibility with existing smoke detectors, compliance with local building codes, and the specific environmental conditions of the installation location. By following these guidelines, a safe and effective fire detection system can be created that will provide early warning of a fire and protect the occupants of the building. Remember to consult with a qualified electrician or fire safety professional for assistance with selecting and installing fire detection equipment. They can provide expert advice and ensure that the installation meets all applicable codes and standards. Regular maintenance and testing of the fire detection system are also essential to ensure that it remains in good working order. Smoke detectors and heat detectors should be tested regularly, and batteries should be replaced as needed. The entire system should be inspected periodically to identify any potential problems, such as damaged wiring or faulty detectors. By taking these steps, the effectiveness of the fire detection system can be maintained and the risk of fire-related injuries or fatalities can be reduced. Different types of heat detectors have varying response times and sensitivities. Fixed temperature detectors activate when the sensor reaches a predetermined temperature. These are reliable but may be slower to respond in rapidly developing fires. Rate of rise detectors, as mentioned earlier, respond to quick temperature increases, making them suitable for areas where fires might escalate quickly. Combination detectors incorporate both fixed temperature and rate of rise sensing elements, offering a balance between responsiveness and reliability. The choice depends on the specific environment and fire risks. When selecting a heat detector, consider its listing and approval. Underwriters Laboratories, or ALL, is a common certification body that tests and lists fire protection equipment. A UL-listed heat detector has undergone rigorous testing to meet safety and performance standards. Ensure the chosen detector is UL-listed or approved by another recognized testing laboratory. Heat detectors have specific limitations compared to smoke detectors. Heat detectors are primarily sensitive to heat, making them less effective in detecting slow smoldering fires that produce minimal heat but generate significant smoke. Smoke detectors are more effective in detecting these types of fires. In areas where smoldering fires are a concern, smoke detectors are the preferred choice. For areas where rapidly developing fires are more likely, heat detectors can provide an advantage. Consider combining both types of detectors for comprehensive fire protection. When installing interconnected heat detectors, ensure the wiring is properly sized to handle the total current draw of all connected devices. The National Electrical Code (NEC) provides guidelines for conductor sizing based on ampacity. Refer to NEC Table 310.15 to determine the appropriate wire size for the circuit. Using undersized wiring can lead to overheating and potentially cause a fire. The interconnect wiring should also be suitable for the signaling voltage and current. Typically, a low voltage wiring such as 18 or 22 American wire gauge or OG is used for the interconnect signal. Follow the manufacturer's recommendations for wiring type and size. When interconnecting heat detectors with smoke detectors, the interconnection signal is used to activate all connected devices when one detector senses a fire. This allows for early warning throughout the building. The interconnection signal is typically a low voltage direct current, or DC, signal that is activated when a detector goes into alarm. The detectors are wired in parallel so that when one detector activates, it sends a signal to all other detectors. The interconnection wiring should be properly terminated and secured to prevent accidental disconnections. Loose connections can disrupt the interconnection signal and prevent the system from functioning properly. Use wire connectors or terminal blocks to ensure secure and reliable connections. When testing the interconnected heat detectors and smoke detectors, verify that all devices activate when any one detector is triggered. This confirms that the interconnection is functioning properly. Use the test button on each detector to simulate an alarm condition. If any detector fails to activate, check the wiring connections and the detector's power supply. Some heat detectors have adjustable sensitivity settings. These settings allow you to adjust the detector's response threshold to suit the specific environment. In areas with high ambient temperatures, you may need to reduce the sensitivity to prevent false alarms. In areas where a rapid response is critical, you may want to increase the sensitivity. Refer to the manufacturer's instructions for information on adjusting the sensitivity settings. The lifespan of heat detectors varies depending on the type and manufacturer. However, most heat detectors have a service life of around 10 years. After this time, the detector's sensing elements may degrade, reducing its sensitivity and reliability. It is recommended to replace heat detectors every 10 years to ensure continued protection. Mark the replacement date on the detector so you know when it needs to be replaced. Proper documentation of the heat detector installation is important for future maintenance and troubleshooting. Keep a record of the detector locations, wiring diagrams, and test results. This information will be helpful when performing routine maintenance or troubleshooting problems with the system. Store the documentation in a safe and accessible location. When working with electrical systems, always follow safe work practices. Wear appropriate personal protective equipment, or PPE, such as safety glasses and gloves. To energize the circuit before working on any wiring, use a voltage tester to verify that the circuit is de-energized. If you are not comfortable working with electrical systems, hire a qualified electrician. Regular inspections of the heat detector system are essential to ensure its continued effectiveness. Inspect the detectors for signs of damage, such as cracks or corrosion. Check the wiring connections for looseness or corrosion. Test the detectors regularly to verify that they are functioning properly. Address any problems promptly to maintain the system's reliability. When selecting heat detectors for commercial applications, consider the specific requirements of the building and the applicable codes and standards. Commercial buildings typically have more stringent fire protection requirements than residential buildings. You may need to install additional detectors, use higher sensitivity detectors, or implement more sophisticated fire alarm systems. Consult with a qualified fire protection engineer to determine the appropriate fire protection strategy for the commercial building. When selecting heat detectors for hazardous locations, such as areas where flammable materials are present, use detectors that are specifically designed and approved for use in those locations. These detectors are designed to prevent ignition of flammable materials in the event of a fire. They are typically enclosed in explosion-proof housings and have special wiring and grounding requirements. The NEC Article 500 provides guidelines for electrical equipment in hazardous locations. When installing heat detectors in areas with high ceilings, use detectors that are designed for high ceiling applications. These detectors have a wider field of view and can detect heat from a greater distance. They may also have adjustable sensitivity settings to compensate for the increased distance. When installing heat detectors in areas with obstructions, such as beams or equipment, position the detectors so that they are not obstructed from detecting heat. You may need to install additional detectors to ensure adequate coverage. Consider the effect of air currents on the heat detector's performance. Air currents can affect the detector's ability to sense heat. Position the detectors so that they are not directly in the path of air currents. You may need to install baffles or shields to protect the detectors from air currents. When selecting heat detectors, consider the aesthetics of the installation. Heat detectors are available in a variety of styles and finishes. Choose detectors that blend in with the surroundings and do not detract from the overall appearance of the building. Some heat detectors can be painted to match the color of the ceiling or wall. When selecting heat detectors, consider the cost of installation and maintenance. Some heat detectors are more expensive to install and maintain than others. Consider the long-term cost of ownership when making your selection. Heat detectors are an important component of a comprehensive fire protection system. By selecting the right detectors and installing them properly, you can help to protect your property and the people inside from the dangers of fire. Always follow the manufacturer's instructions and consult with a qualified professional when installing and maintaining heat detectors.